Touchscreen use in vehicles introduces conflict for the visual attention of drivers. This conflict increases crash risk and has been a subject of concern among driving researchers for many years. This has sparked efforts to develop new in-vehicle information systems that reduce the demands for drivers' visual attention. Recent technological advances have made it possible to cheaply and effectively measure hand positions of drivers using infrared sensors or computer vision. Some researchers have recently begun exploring these technologies as an effective means to develop in-vehicle control systems that are easier to use and reduce the crash risk associated with using traditional methods. At the Mind Music Machine Lab, we are working to expand upon the successful attempts of such systems. Using the Tri-M system, the driver's hand acts as a cursor as they navigate through different traditional menu structures such as lists and grids. To reduce the visual demand of using a gesture system, we used auditory displays to convey information about cursor position. Well-designed air gesture controls supported by auditory displays could supplement or even replace the need for visual information to use previous systems, allowing drivers to focus visual attention on the road while operating in-vehicle controls eyes-free. To test this system, we completed successive experiments using a driving simulator. Participants were asked to complete simple navigational tasks using the gesture controls while driving on a winding road. We collected driving performance data from the simulator and used an eye tracking camera to track eye gaze during the drives. In our first experiment, we found that adding audio can improve eyes on road time and reduce the driver workload without degrading menu navigation performance for simple menu navigation. Our second experiment focused on the question, is the air gesture control better than the touchscreen? It was only when adding the auditory displays did the gesture controls show less visual distraction compared to touchscreen controls. Driving performance and workload were comparable. In our next experiments, we found that control orientation does not influence performance, but vertical control tended to reduce subject workload, and auditory-only displays led to reduced driver workload compared to visual displays. In our Experiment 5, Gesture Elicitation, and Experiment 6, Sound Card Sorting Task, we sought to gather feedback from end users to incorporate into our future design iterations. Our last experiments focused on answering the question of whether user preference mattered for sound design. We found that not only does it matter, but other in-vehicle sounds, such as cabin noise or other in-vehicle technologies, should be considered when working on the sound design. Although many questions were answered, there are still gaps that designers and researchers should consider to make a car even safer. Because of this, our next steps include working on a possible in-vehicle gesture interface interaction scenarios for passengers and kids, and integrating other modalities with sounds, such as tactile feedback, for in-vehicle interfaces.